So anytime we're asked to prove that a triangle is some sort of triangle on a grid or any other kind of thing that says to prove us something on a graph, we need to draw a picture of it and then find the slope and the distance of each of the sides. And then after I find the slope and the distance of each of the sides, I'll be able to answer the question using properties and things that we've already talked about before. So I'm going to draw this triangle. So 0, 2, it's obviously very important that I get these in the right spot. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, negative 1. So x, and negative 3. Now, maybe before I start, I want to think about what an isosceles triangle is and write it down. Maybe I don't, it doesn't really matter. I suggest that every time you do one of these, you make a little chart here. So slope and distance. And what I'm going to do is I'm going to do that for each side. So x, m, x is z, and then so this is going to keep me organized, all right, so I can get this stuff done. So I'm going to go to the graph, I'm going to draw in what I would need to find the slope. I like to go clockwise around the outside, but it doesn't matter, but make sure, remember that we haven't done slope maybe in a little while. It's important to have your directions on your slope so you can make sure that you're positive and negative, right? So 1, 2, 3, 4, 5, up, that's positive. 1, 2, 3 to the right, also positive. 2 to the right, positive. 1, 2, 3, 4, 5, 6, 7, 8 down, that's negative. 1, 2, 3, 4, 5 to the left, that's negative. 1, 2, 3 up, that's positive. So there's all my numbers I need to write my slope down. So just be careful here that you put rise on top, run on the bottom. So xm is rise 5, run 3. mz is rise negative 8, run positive 2. And x, oh, that's in the wrong spot. Sorry. That's mz. xz is rise 3, run negative 5. Okay, so I got the slope. Now to find the distances, I'm going to do the Pythagorean theorem for each of these. And remember that I'm not going to use any negative numbers when I do Pythagorean theorem. Okay, so I'm finding xm here, it's got a 3 and a 5. That is 25, 34. I would take the square root of both of those, so I would get square root of 34. And just like anything else, I don't care what the decimal is. I'll do that if I need it. Okay, xz is again 3 squared and 5 squared again. Now, if you reduce any slopes in this column right here, I'll highlight it for a second. If you reduce any slopes in that column, make sure that you don't use those numbers to do the Pythagorean theorem. Make sure you go back to the original graph and use those numbers to do the Pythagorean theorem, or it'll mess up your distances. So this is going to be 34 again. All right, so right away, I probably noticed that I have 2 sides that are the same. Now, I shouldn't have 3 sides that are the same, so I should check that. So 8 squared and 2 squared is c squared. That's 64 and 4 is 68. And that's going to be square root of 68. Okay, so I have 2 equal sides. So it says prove that it's isosceles triangle. So I always start these off with based on my calculations for 3 reasons. All right, number 1, it tells me personally that I should have done some calculations. And if there's no calculations there, I have a problem. All right. Number 2, it tells the person reading it that I did calculations, and maybe they aren't right here, but maybe could you go look at my graph and see if you see them. Okay. And number 3, it makes me sound like I know what I'm talking about, which you may think is kind of silly, but that's one of those things where if you look at somebody or you listen to somebody and they really sound like they know what they're talking about, they're much more believable. All right, and that's a good thing when you're trying to do something like this. So based on my calculations, what did you figure out? All right, I figured out this triangle is isosceles. So triangle MXZ is isosceles because it has 2 equal sides. Okay, I should write in a decent sentence, I guess is the way I'm looking for here. All right, I'm going to go like this too up in my work. I'm going to show that they're equal like that. All right, because that kind of gives the whole picture there. Now, that's easy for someone to understand. Really, that's not that complicated. Is it going to take a little while? Sure. I got to find 3 slopes. I got to find 3 distances. Okay. Could you get away with leaving some of those out? Possibly, if you know exactly what you're doing, but I would not suggest that you try to do it that way. If you stick to this method, you shouldn't lose any silly points in anything that you're doing.